welcome back, and we're on lesson 3 of matrices, and what we're going to be looking at now is the scalar multiplication of matrices. And what does that mean? Fancy term, but all it simply means is multiplying a matrix by a number. So that's what scalar multiplication is really all about, multiplying a matrix by a number. So let's look at example 1. Okay, so what if we were given this question? Okay, so we're given a matrix, and that matrix is called A, and that matrix is here, and obviously it's a 2 by 2 matrix, etc. But matrices are normally denoted with capital letters, etc. So they're telling us given matrix A equals 2, 5, 3 and a half, determine 5A. Now, as we said before, a scalar multiplication of a matrix is simply multiplying a matrix by a number, and that is pretty straightforward. So all we're going to do here is simply multiply matrix A by 5. Now, when that happens, it means that every single element in that matrix is going to be multiplied by 5. So, to do the solution to that question is very simple. So all we're going to do is multiply matrix A by 5. So it will be equal to 5 times 2, 5, 3 and a half. Now, all we're going to do here is multiply each of these elements by 5. Alright, so simply 5 times 2 is 10, 5 times 5 is 25, 5 times 3 is 15, and 5 times a half is the same as 2.5, or 5 over 2, or 2.5. So I can simply put 5 over 2, all right, or 2.5 or 2.5, that would be fine. So again, scalar multiplication is just simply multiplying a matrix by a number. That's what it's all about. That's what scalar multiplication is all about. So again, given matrix A is that matrix, we're asked to determine 5A, which means simply multiplying matrix A by 5, and that would be your result. Let's look at another example. Okay, so example 2. Okay, so what if we were told this? Okay, so here we have a matrix called C, and obviously that is a 2 by 1 matrix, and we're asked to determine a half C. So it simply means we're going to multiply matrix C by a half, and all elements inside matrix C will be multiplied by a half. So what would a half C be equal to? Well, a half C would simply be equal to a half times whatever matrix C is, and that's 3A minus B. Now, just for emphasis, even though we didn't do that for the first example, just for emphasis, what you're doing is you're multiplying each of these elements here. 3A is one element, negative B is one element, by a half. So it is often a good idea to write this step just for emphasis, especially when it comes out a little bit more technical question, and I'm going to get to that in a bit. So of course, a half times 3A is the same as 3A over 2, and a half times minus b is minus b over 2. So this is what a half c would essentially be equal to. All right, for those persons who might not be seeing why a half times 3a is 3a over 2, remember that 3a is the same as 3a over 1. So when you multiply the numerators and the denominators, this would be the result. Okay, now let's look at another example. Okay, so what if we were given this matrix? So this is example 3. We're looking at example 3 and we're given matrix B, and this matrix is x minus 1, 4y, 3, and let's say 2x plus 1. Now, red flag immediately. Whenever you have matrices that have algebraic expressions in them, whenever you have matrices with algebraic expressions in them, you must be very, very, very careful. So they give us this matrix B and they ask us to determine to B. So it means we're multiplying matrix B by 2. So you have to be mindful now, especially when the matrix has algebraic expressions in there. And that is very, very important to know. Okay? Now, solution. Quickly. So 2B would simply be equal to 2 times whatever matrix B is. Okay, now very important. Now a lot of students tend to make errors when they move from this step. And the error is as a result of something that they're not mindful of. Now, whenever you have algebraic expressions, before you proceed to the next step, it is a very good idea to note that once it's an algebraic expression, you have to place them in bracket. And if you don't, and you write a line, for example, like this, just take a note of, remember, each element is going to be multiplied by 2. So the common mistake students make is that they forget to put the brackets around the algebraic expressions and they write a line like this. For example, we have 2 times this element here, but this element is x minus 1 and it must be bracketed, because if you do this step, then only the x is being multiplied by the 2, and that's where you're going to get the thing wrong. So be mindful of that, okay? So that's why I'm emphasizing the need to have the bracket. Extremely, extremely, extremely important, okay? So again, what we want to have here is 2 open bracket x minus 1, and of course expansion is going to take place there when you're ready to complete the problem, and 2 times 4y and 2 times 3. We have another algebraic expression here, so it's 2 open bracket 2x plus 1. It is extremely important to have the brackets present, or else your step is going to be deemed incorrect. So I just want you guys to be mindful of that. So let's complete the problem. So simply 2 times x is 2x. 2 times negative 1 is negative 2. And that's the completed expansion for this part. 2 times 4y is simply 8y. 2 times 3 is simply 6. And here we have another expansion to do. So 2 times 2x is simply 4x. And 2 times positive 1 is simply positive 2. And that is what 2b would be equal to. So again, whenever you have algebraic expressions in a matrix and you're asked to do scalar multiplication, always put the algebraic expressions in bracket, because when you come on to the multiplication, you have to be now mindful of how you're going to write the next step, because without the bracket, it's going to be wrong. Okay? Quickly review. Again, scalar multiplication of matrices simply means you're multiplying a matrix by a number. So if we have matrix A here with these elements, this is a 2 by 2 matrix and it has elements 2, 5, 3, a half, and we're asked to determine 5A, it means we're multiplying matrix A by 5. And how we go about doing that is that we multiply each of these elements by 5. And when we do that, 5 times 2 is 10, 5 times 5 is 25, 5 times 3 is 15, and 5 times a half is 5 over 2, or 2.5, or 2.5. Here we have another example. Given C equals 3A minus B, and we're asked to determine a half C, which means we're multiplying this matrix, which is C, by a half. So a half C would be denoted this way, and of course, just for emphasis, and actually this step is what I would want you to do, because it's going to be very, very important when you come across algebraic expressions in matrices. So a half times 3A, and a half times negative B. And of course, 3A is the same as 3A over 1. So if I multiply numerator by numerator and denominator by denominator, the result is 3A over 2. And a half times negative B is simply negative B over 2. And that would be a half C. Next example that we looked at involved algebraic expressions, and that's where you should pay most attention to. Once you see algebraic expression and you're asked to do scalar multiplication, then ensure that the algebraic expressions are put in bracket every single time. Because when it comes down to this step, without the bracket, then you're going to get that step wrong. So put them in bracket immediately, so that you don't make any mistakes and lose any marks and get the thing wrong, essentially. So, of course, when you have the bracket now, it's straight up expansion. 2 open bracket x minus 1 will result in 2x minus 2. Obviously, 2 times 4y is 8y, 2 times 3 is 6, and here's another case of expansion. 2 times 2x is 4x, and 2 times positive 1 is 2. Okay, please review this video as many times as you want, and give me some feedback and comments, and I hope you found this video insightful, and I'll see you guys on the next video.